All right. Today's session, we have 6 presentations, and we're going to dive into critical standards, technologies, things that are shaping the future of avatars and 3D assets. These topics really represent significant progress toward open standards and interoperability and creator development and really helping to allow these platforms to collaborate seamlessly. So I will encourage you to hold your questions until specified Q&A sessions. Some presenters will have some time at the end that they've reserved for questions. Others have so much info to share that where they're going to ask you to hold your questions until the Q&A session. So if you could just hold your questions and your thoughts and your perspectives until we ask for a Q&A, and I will be your timekeeper tonight as well as your host. I want to introduce you to Ken Jakubzak, who is from Meta, who also chairs the Metaverse Standards Forum Characters and Avatars Group, and also the Khronos Character Extensions Working Group. So if you want to say hi, Ken.
Hi everyone. Just a correction. I don't chair the
Oh,
MSF group,
oh,
just
sorry.
this one. But I mean, I appreciate it. But in any case,
Sorry.
so glad for all of you to be here. I think this is a really important conversation, and one of many that will need to happen in the coming year as we start to talk about this particular topic and get folks together to really think about this and start to contribute towards open standards. So, well, starting to talk about it. Anyway, not to get ahead of myself. Thanks.
Thanks. And that really is where we want to go, right? Is to look at what standards are possible here. So with that, I will not waste any more of your time with me talking. Tonight, kicking us off is Imed Bouazizi from Qualcomm to lead us into MPEG avatar representation format. So Imed, I'm going to turn it over to you to start sharing and kick us off. Thank you.
Thank you very much, Amanda. Let me share my screen. And good evening, everyone, or good afternoon. I'm Imed Bouazizi. I'm with Qualcomm as a Director of Technical Standards. I work on, among other things, the avatar representation format at MPEG. And that's the subject of this talk. So this work started a few years back. I think there was a realization that the industry or the avatar ecosystem is very fragmented. That's probably why everyone is joining this session to see how we can address that problem. There was a realization that we came to quite early, which is that maybe it's bad news, but it's unlikely that the industry will converge into a common rig or a common blend shape set or a common landmark set. So I think that was very obvious from the start, and we see it like every day. Like we see plenty of proprietary formats out there. Different tools have their own like rigs or their own like blend shape sets and so on. So MPEG set a goal for itself to develop sort of like an exchange format instead of like adding to the problem by defining yet another like standardized rig or skeleton and blend shape set and so on. So we want to enable these different formats, these different rigs and avatars created with these different tools to interoperate or to like work together, so to say. And the idea there is a user will probably not want to create their avatar like 100 different times, one time for each application they use, for each metaverse world they join, in VR or something like that. It will be like a create once and use pretty much everywhere across different applications and experiences. I think that's the goal there. Now that sounds, of course, very enthusiastic and ambitious, but of course, like the devil is in the details. So what we look forward to is to hear like feedback on this and if we're going on the right direction here. We wanted to like keep alignment with standards like OpenXR and so on, since we believe that the tracking will come from like these existing tracking APIs. Like OpenXR has a bunch of extensions that enable tracking. You have like other tools like MediaPipe and so on, libraries that enable this tracking, and we want to use these to animate the avatar. Now, again, I talked about this, so why we believe it's hard to converge. I think I said like lots of engines and tools, they will always use their own and prefer their own like workflows and their own like rigs, because they have optimized their tools to create the avatar with these in mind. So it's going to be hard to converge or force everyone to use a standardized rig, or even like standardized naming for that matter, which is at least like for humanoid avatars, one could think that we could just use the medical naming for like the different joints and bones, but that's not happening. For tracking, we see the same, like even in OpenXR, there are, I said, like so many different extensions there to like do tracking of face, body, hands, and so on. Where hands, there is some conversions there, luckily, but you cannot extend that beyond the hands, unfortunately, for some reason. Also, like simple things like landmarks, facial landmarks. So we see a huge difference. Like MediaPipe, for instance, is tracking 468 facial landmarks. ARKit is using 1220. It's huge like gap between the two. So it's really quite fragmented, and we believe it will stay so. Now, how does ARF or ARF attempt to address this? Let's talk about the format itself. So it's a container format. It's like composed of like a descriptive document. So that's the first thing you find in the container. It's using like a zip container. Once you get into that zip container, the first thing you'll want to parse is the ARF document, which describes like the existing assets in that container. Like this will start with some metadata, like who is the user, what's their age or gender, things like that. But then it will dive into like things like what skeletons are defined here. So you can like even have multiple skeletons or rigs in the same container. You can have multiple blend shape sets, multiple landmark sets, and so on in the same container. It describes the hierarchy of these assets, like how they fit together, what each asset is meant to do. Like this is a head, or this is a jacket, or things like that. So that's what it does, and then it provides like all the pieces needed, like all the geometry or meshes, all the skins, the textures, everything that would be needed to render this avatar. An important piece that it provides is what animation frameworks it supports. Like, can it be animated with OpenXR tracking, like a specific OpenXR extension, or a specific, does it conform to specific blend shape set? So now, what we really want at the end, ultimately, is to be able to create a registry with URNs, basically, where you could go and say, okay, this is maybe the Meta Facebook, Facebook or Meta facial tracking extension 2, for instance, that's defined in OpenXR. So Meta will define a URN for that potentially. So we want to create like this registry so that once you read that, you know, okay, what rig this is using, or what blend shape set. But most importantly, you don't need to understand that rig. You need to just understand how to map one animation framework into one like blend shape set, even if they are different. So I think that's a key part we define here retargeting, and we'll get to that. So what is retargeting? It's basically transferring motion or expressions from one avatar model to another. So let's say you created your avatar to work with an OpenXR rig, but you're receiving your motion, like your facial blend shapes, for instance, from ARKit, which has 52, for instance, blend shapes. So you want to be able to still use that same animation stream to animate your head, or like the talking head of the avatar. And that happens through retargeting. So what we provide in ARF is a possibility to define retargeting maps or tables. So you could have linear and non-linear associations between shape keys from a source and the target framework. So you can describe that mathematically, basically how to convert from a set of animation weights into a specific weight that you use to animate a target shape key. You can do the same for the skeleton animation and also for the landmark. So that's what these mapping tables offer. If linear and these non-linear operations are not enough, we have provisions also to include pre-trained neural network models which would do this conversion. Now this all sits on the premise that the IDs or these shape keys are well defined, again, based on these registered URNs, so you'd know specific, if I'm using specific rig, then bone number 15 is exactly bone number 15 wherever you go. So the mapping table, when it points to bone number 15, we're talking about the same bone. So I think that's what is required. So that's why we believe registration or creating this registry would be very important. On the use case, so we want to leverage this in communication use cases or shared experience use cases, like people joining the same metaverse world, or on Zoom, maybe it will be like a 3D experience or an immersive experience where people join with their 3D avatars and they can talk and interact with each other. We can leverage interactivity as well, so they can interact with the virtual environment and so on. So that's the use case. So people will be probably wearing glasses, smart glasses with tracking, or HMDs, and they will be able to, well, they have cameras in the room, it doesn't really matter. And that will create these animation streams. They are sent to the other participants or the other people in this shared world or shared space. These other participants already downloaded or pre-downloaded the user's avatar, and they are able to animate it. So that's the main use case that we're targeting there. And the communication, of course, can happen over WebRTC or something similar. The animation samples were taken pretty much directly from what we saw in OpenXR. We want to maintain OpenXR compatibility, but also we inspected other tracking frameworks like MediaPipe and so on. So basically, we want to have it's pretty common or universal what we exchange there. So for joints, it would be the joint ID with transform matrix. You can have velocity or things like that. For blend shapes, you will have the blend shape, the shape key ID with a weight and potentially also confidence value. For landmarks, it would be the coordinates of the landmark and so on, whether in 2D or in 3D. What MPEG is currently working on, so we finalized the main specification or the main standard. Now we're working on the compression of these animation streams. So we want to bring that down to sub-megabit per second. Key use cases in these communications where you have maybe tens or hundreds of participants if you're receiving the animation streams from everyone. So that should be reasonable still. Probably we're targeting more like 100 kilobits per second, actually. But what we see here is an example of like landmark compression. We see that the colored points really are the compressed, reconstructed landmark positions and their deviation from the original or the uncompressed reference. So we can achieve quite good compression ratios. So it's still exploratory. We're reaching like compression factors of 20 easily. And we hope that this will improve over time. The goal is to release animation compression specification by end of 26, so end of next year. I think that's pretty much it. I want to end my talk with some pointers. So the specification is available as an ISO specification, 2390 part 39. There are already implementations, like we have, of course, MPEG develops reference software, which can be accessed on request. There are also like web and Unity implementations. There is also Blender exporter that converts like an armature or like a rig in Blender into ARF container. And with that, of course, I want to call for action. So please read the specification. Please share your inputs and also your impressions on the direction we're taking. So MPEG is open for this. We'll have ways to like change or address new use cases, and we'll be glad to do that. With that, I know I'm a bit early, but maybe we have some time for a few questions.
We have about 1 minute if there's like key question out there. Any you want to raise your hand if anyone has a question? We probably have time for one right now. All right, I don't see any questions. Please feel free to bring up your questions or perspectives when we get to the roundtable discussion. Thank you so much, Imed. I really
Thank you,
appreciate
everyone.
it.
Thank you.
All right, now we're going to move over to Ken Jakubzak, who is going to be presenting from the Character and Avatar TSG group in Khronos. So that was my confusion before, I'm sorry. He's going to be presenting on Khronos character extensions. So Ken?
Hi, everyone. Thanks for having me. So my name is Ken Jakubzak. I am the chair of the Khronos Character and Avatar TSG. We recently were formalized as part of the 3D Format Working Group, and our focus is character and avatar extensions. So our goal is to enable a set of extensions that allow anyone to establish a character or avatar and define it and structure it in a way that can be read across the slew of glTF compatible surfaces, whether it's VRM, who are our partners in this effort, an organization or institution's avatar, or a homespun avatar. Just a little bit of history on the effort. Back in October 2024, Khronos and the VRM Consortium announced that we were collaborating to evolve both glTF and VRM as global open standards for 3D interoperable avatars. And since then, from December to October 2025, we've been working together on this initial set of general purpose character and avatar extensions, which if you go to GitHub right now, you can see is a pull request on the glTF GitHub. As of last month, we formalized the interim working group into a formal working group, and we are now focused on a long-term plan for characters and avatars in general. This next slide, I will say, because we're early, these are some of the areas that we're looking at trying to address next with our extension sets. We haven't actually started it or scheduled it, but this is generally what we're thinking. Character animation is going to be very important. animation graphs, behavior systems, retargeting, runtime informing labels, metadata ontologies, character and character asset simulation. Figuring out how we can represent and portray this through glTF extensions is top of mind for us. And we also acknowledge that we're going to have to be collaborating with our fellow 3D format working group TSGs on things such as how does physics work with a character and avatar in the sense of being able to portray the glTF physics extension that's coming up in tandem with these extensions. Interactivity, audio, rendering, material, all of these things require cross collaboration. And so from our perspective, like we are going to be working with all these various groups to figure out within this area what makes sense to push forward as extensions. So to that point, I'd like to talk a little bit about our goals and our philosophy behind how we approach creating character and avatar extensions for this effort. We believe that the extension should be a series of building blocks. You can take what you like, you can leave what you don't. But at the end of the day, we create a pathway for folks to create a self-describing character avatar through the glTF extension composition. And to do this, we need to create a flexible basis. We can ratify what we know won't change, but we don't prevent the use of heavily opinionated properties or characteristics. So you might have seen this slide before. I've presented it a few times. This is our thoughts on the VRM glTF extension convergence. Today, VRM 1.0 is a opinionated standard that enables VRM avatars to be loaded into VRM APIs across a slew of different applications, and it's built on top of glTF. And so as we've been building out this first phase of extensions, our goal has been to take those, take the underlying subset of functionality that can be represented in granular extensions and to suss it out and to make it so that it can be more generalized and used across the board. And so our intent in phase one is for them to refactor on top of that and to use what they like to, as I mentioned before, take what they like, leave what they don't, and then iterate on the VRM standard using that as the basis. But then as we go forward, we want to expand our character enabling extensions. As you saw, like we're thinking about more generalized animation extensions, metadata, et cetera. So at that point, we want to figure out what actually is valuable to people. And so as we start to, and have already started to, reach out to various groups and organizations, we want your feedback. We want to hear what actually will provide value to you as you try to build characters and avatars on top of these extension sets. But as we do this, we sort of need to balance rigid structure and flexibility. So to encourage wider adoption, we're focusing on flexibility first. We don't want to define opinionated concepts like skeletal and expression vocabularies in our earlier stages because it makes it harder for organizations and institutions to adopt them from out of the gate. In the previous presentation, this was something that was called out. I fully agree with it. I think it is something that is hard to agree on, especially when the folks that are trying to adopt, say, a standard have not come to the table and been part of the conversation leading up to that standard being produced. And so even though this is our philosophy from the get-go, which is to focus on flexibility first, we simultaneously understand that interoperability sort of demands either standardization in data composition or in the ways to translate these common concepts. And so for us, this translates into a call to action. We need to contribute to whatever translation frameworks are being developed across the industry for characters and avatars. And at the same time, we want to push conversations around standardizations for character concepts that are common and maybe not controversial, but also maybe some that are harder to agree on. Like maybe to some extent, we do try to push for some sort of skeletal or expression vocabulary, or at least some way to derive one. In a bit of a topic switch, I do want to talk about where we're currently at with our phase one extensions. So the base extension that we have is just KHR character. It indicates that a model is a character and provides structured guidance around what metadata to have on it. We also have KHR character avatar, which denotes that something is an avatar rather than a character, but I don't want to focus on it because as you will find out after this slide, these are about to change a little bit. We also have skeletal and rig extensions, which enable things like biped classification, provides additional bind pose storage for compatibility purposes, and joint remapping mechanisms. Similarly, in expressions, we have extensions to define facial animations for morph targets, joints, or textures, as well as remapping mechanisms. And in additionally, things for providing additional context, like is it procedural or not? Apologies. Lastly, we have annotation extensions, things that help define things like per mesh metadata, as well as defining whether like a mesh exists in one view versus another, like first person versus third person, as well as attach point extensions. But with that in mind, as I alluded to, we are revisiting this a little bit. And so while we've created a subset of extensions that represent a portion of the functionality that VRM provides, we're now taking a look at the big picture now that we're a TSG and trying to assess whether portions of that should be delayed and then bundled with similar extensions that then provide more meaning and may mean that they would be restructured or even composed completely differently. So right now, we're going and taking a look at all the extensions that we have in our current proposal, and we're assessing whether it needs to be amended / modified, delayed, as I just mentioned, or just completely removed. And so in the next few weeks, take a look at the PR. You will see some changes, and we'll explain why the changes are being made. But until now, we've been trying to figure out how we balance where we're currently at, as well as where we want to go. And so with this sort of directional shift, with us focusing on scenario-driven analysis, we're now trying to frame our future set of extensions in the same context and figuring out how to bundle them. And so in the future, as we continue to iterate on these extension sets, we're not going to have bag of everything proposals like this first one was. Instead, each proposal will be heavily focused on a specific category. So it might be animation, it might be additional contextual metadata, it might be materials, it might be working with the physics DTSG to figure out how the physics and secondary animation extensions would look. Simultaneously, we want to work with you all. We want to collaborate, and we want to communicate with the greater community on what it means to have overarching character standards that can exist alongside formats to help us actually standardize how we convey, organize, and represent these higher level concepts, particularly ones that maybe aren't ones that are something that people can't agree on, like, say, vocabularies. Maybe it's something where it's a little less controversial. And so we can start there and then get to the more complicated topics. Here's an example asset flow. Like, let's say hypothetically, in a perfect world, we had a shared character and avatar set of standards that are asset format independent. You could have your USD or glTF character asset that is being modified and iterated on in your asset authoring tool of choice, whether that's Blender, Maya, Houdini. And then that could either spit out into an asset processing pipeline or spit out to its direct end format, whatever transmission format you choose. In this case, glTF, because we are Khronos. The thing that I want you all to keep in mind as you look at this diagram is that there are concepts that need to persist from asset creation and authoring and iteration through processing and munging in whatever pipelines a character asset is being manipulated in to its final transmission format that then needs to convey those concepts to the runtime or platform/engine. And so having these standards that kind of persist beyond just asset formats and perhaps also persist in things like platforms, runtimes, and engines means that we can start to have a conversation around concepts rather than just say the nitty gritty, like, oh, yes, the head joint is head underscore JNT. And so this is really a call to action around these interoperability challenges that we know will exist, but functionally, it is something that can only be addressed by us working together and talking about it. So I could go through all of these challenges here. I think I'm probably starting to run out of time, so I am going to choose to not actually run through each individual one. Instead, I just want you to look at this and think about how maybe in your day-to-day, maybe in the times that you interacted with characters or avatars in the context of the project, you've met these challenges or had to deal with these challenges and had to spin up your own solution to overcome them in a way that maybe you've had to do before, and maybe you've had to do it many times. There's this saying where if you have to write the same code in two places in the same code base, it makes sense to create a function to then call into it. In this very similar way, it feels as though we are trying, or should be trying, to reach a place where we remove that redundancy of repeated work. And these interoperability challenges, to a large extent, are representative of that. So again, this is a call to collaboration. We can only solve this with the greater community being involved. The Khronos character and avatar TSG is planning on contributing to this effort and collaborating with the MSF 3D Asset Interop group and their character-focused subgroups to iterate on whatever character and avatar translation frameworks they are iterating on, as well as to start conversations around generalized avatar and character standards that span beyond formats and perhaps even platforms. So with that, I think I'll just end it with, here's the link to the pull request that's currently out. There's also the QR code. So if you want to access it that way, feel free. A reminder that we are going and reviewing these very, very soon. And so it will change in the next few weeks. But if you want to take a look at the current state of it and provide feedback, even if it's damning feedback, which I think we should embrace, please go ahead and do so. Again, thank you so much for the time and the opportunity to speak to you all. Yeah, I don't have anything else at this point.
Thanks so much, Ken. Yeah, I'll just emphasize the need for collaboration, whether it's Khronos, whether it's MSF, whether it's AOUSD, whether it's a different organization. We just really appreciate that these types of community town halls allow us to get feedback and only become better in the industry. So thanks, Ken. I appreciate that from a Khronos perspective. Now we are going to move to Observer from VRM Consortium, who's going to speak on VRM and interoperable 3D avatar format for VR. Observer?
Yes. Can you hear me?
We can hear you and we can see your screen. Thank you.
Okay. So thank you for having me. I'm an observer from VM Consortium. Today, I would like to give a short introduction to VRM, interoperable 3D avatar format for virtual reality users. VRM is a 3D avatar file format made by Duango in 2018 and currently maintained by the VM Consortium. The file extension is .vrm. A single VRM file describes a humanoid model. And VRM is mainly used in the Japanese avatar community, but it's also supported outside Japan. VRM is based on glTF, and VRM is defined as a suite of several extensions. VRM extensions have features to treat 3D models as an avatar. Since VRM is built on top of glTF, VRM files can be opened using glTF applications that don't support VRM. However, the expressive capacity is limited in such environments. VRM models can be created in various ways. For example, we provide a defined implementation of VRM called UniVRM, which works with Unity. Users can import 3D models created in Maya or Blender or some DCC and add several VRM components and export them as a VRM file. There's community contribution that adds VRM support to Blender, allowing users to export VRM models directly from Blender. The easier way to create VRM is with a Build Studio. Build Studio is basically a character editor tool that exports VRM format. VRM models can be used in many applications thanks to the community. For example, joining a metaverse, of course, or becoming a VTuber with a facial tracking feature, or letting avatars walk in real life and take a photo. There's 70 or more registered applications in Build Hub, which is a VM platform service. And there is more, including small web applications. There are many libraries that enables us developing VM applications. We have an official Unity library, as I said, and there are many community contributions like for 3JS, Babylon.js, Unreal Engine, and Godot or more. Let me talk about the philosophies behind VRM. First, VRM must be platform independent. Avatars must not be locked into a single platform. It also must not be locked into a single game engine or backend. The same avatar file must be used everywhere. So we are being careful not to include features that heavily depend on game engines. Second, VRM must have enough expressiveness for VR users. VRM has features specific to the metaverse culture. It also has a license fields to reflect the author's view on how an avatar should be used within the community. And lastly, VRM must be easy to use or implement. This slightly overlaps with platform independence, but VRM has opinionated restrictions and features that makes both users and developers happy. And the VRM spec comes with a documented behavior and reference implementations to make avatars look consistent between platforms. These are actual features of VRM extensions that put life into a glTF model. We have a humanoid bone structure, features to control facial expressions, definition of tone materials, the position of the avatar's first-person view, or the eye look rotation, physics-like secondary animation called spring bone, constraints for complex bone interaction, and meta information, such as author name and licenses. We will not cover all of these features due to time constraints, but I will explain some of them. Let's look into the humanoid of VRM. We have a standard humanoid bone structure in spec. So applications that support VRM can control any VRM avatars with the same bone structure. The application don't have to infer the correct bonds that the application wants to control. Tone material is an important one in VRM. VRM has a definition of tone materials that enables anime-like material expressions. This is essential for the Japanese avatar community, like VRChat, since almost all avatars use tone materials. Since the appearance of avatar has to be same between platforms, we have a detailed documentation of the shader implementation in spec. Spring bone is a feature that allows bones to swing as the avatar moves. It is helpful to put dynamics into hair and curves. Like tone materials, spring bone is desirable to behave the same between platforms. So we have detailed documentation about the calculation in the spec. VM also defines meta information, The metafields include avatar license properties that enable authors to state how users can treat avatars. For instance, if an author doesn't want the people to treat their model violently, they can explicitly state that the model prohibits violent acts by setting the corresponding license field. Since the license fields mainly consists of true or false values, I mean Boolean value, the application can show the license of the model in a summarized UI. The application can also control model use or filter available models using the value. Yeah. Currently, the VM Consortium is collaborating with Khronos Group to make a step towards establishing an interoperable avatar standard. VM has historically been specific to the Japanese metaverse use cases, driving an avatar format supported by the community for 7 years. And now, we, Khronos and VMC, are currently working on a global standard for the avatar format that can be used across industries. The VM Consortium is helping make a global standard both accessible and expressive from our perspective. So that's my introduction of VM. Any questions?
Thank you so much, Observer. That was really, really cool. We do have time for questions now. So if you have a question and would like to ask Observer any questions about that presentation, please raise your hand. Jeff.
Yeah, I guess quick question. So I know that the MTune shader has been a big part of VRM, but I wonder if there's still like a thought towards supporting PBR materials like in glTF and still kind of having that be valid VRM for maybe more realistic style avatars.
Yes, while we have M2 for two materials, you can also use PBR materials that glTF core spec supports. Actually, my current avatar uses PBR materials on the top of my hair, the accessory.
Okay, cool.
Yeah. Thank you.
Thank you, Jeff. Any other questions? Aaron.
So I just want to actually build upon the previous question with a bit of a comment. I would hope that the future of the M2 the tune shading stuff ends up as a general purpose extension and not just like an avatar specific one, because it is, I think, totally valid to want to have like a tune shading on a non-avatar object that you have in the world.
Yes, I think so. Yeah. Actually, the VIM M2 extension is an independent extension. So if the platform supports it, you can probably use the M2 extension independently for no-avatar objects.
Great.
Thank you for the question.
Thank you. Jeff.
And for that matter, it's maybe a little outside of just the scope of VRM, but having custom shader support in glTF, I think, is something that would be useful as well in the future.
Yeah, that will be so cool, but it's probably very hard to make a specification. So we are currently considering if we can do something around Material X, because Material X also has a NPL features, but we are still investigating right now.
And I will take off my MSF hat and put on a Khronos hat really fast and say, we welcome you to come join us at the 3D Formats Working Group and working on glTF and Khronos as well if you have those ideas. So the good thing is, as you've been seeing tonight, is that, you know, VRMC and Khronos and MSF, we do want to collaborate together. We do want standards that are best for the community, and interoperability moving forward. So thank you so much for your questions. And there's yeah, it's really great to explore these aspects of VRM and glTF and USD as we move forward. Any last questions for Observer? All right, thank you so much, Observer. We really appreciate your presentation.
Thank you.
All right, now we're going to move on to our next presentation by Joe D. Williams and Don Brutzman from Web3D Consortium. They'll be talking to us about HAnim and X3D standards, capabilities, and prospects. Joe.
Hi, I'm Joe, Web3D Consortium. I've been working with HAnim and the VRML to X3D conversion, and a continuing World Wide Web enthusiast. I've been retired working from home since '97. When we think about X3D graphics, we gotta think that we're standing on the shoulders of giants. They left us a lot in the form of real-time interactive 3D graphics creation and delivery. There's been a new dictionary just come out and with some new words, but there's still a lot of old words with still the same old meaning. Basic standards represent a starting point that's extensible. It gives the user a basic, open, and free interoperable form that can be developed using standard interoperable web resources. I want to introduce Dr. Don Brutzman. He's an early contributor based in Monterey, California. He's recently retired, but already has a shingle out. Don is a senior spec editor and motivator for Web3D Consortium, working with implementations, implementers, and other spec editors. Anybody ISO curious would meet with another senior member, Dick Puck. I just had to mention Dick as a longstanding contributor. And so here is Don. Thank you.
Thanks, Joe. And I guess I'm also a slide monkey in Avatar land, but happy to blast you guys through a whole bunch of stuff. But at the end, quite simple. And I think, Joe, you're communicating it correctly. It's pretty profound what this might do. So Web3D, well, we are a standards development organization. We're grateful, happy to be right in on the ground floor with MSF. And we have two standards that relate here. They are closely connected. They have been iterating through International Standards Organization, the whole rigor process. Web3D produces the specs, they go out there. There are no royalties in any of our standards, and we try to be interoperable, not just conceptually, not just with the data, but also in terms of what formats can you use, what programming languages, etc. And we have a working group and liaisons in this matter. Boy, it's we've been busy. We first started way back in '94 at SIGGRAPH, and actually the dialogue about 3D on the web and human animation followed shortly thereafter, and it's sort of been tracking all along. And you can see that we've been deliberate through multiple versions, very iterative. We have backwards compatibility because we're very careful before we add something. And a key part of our progress has been the Web3D conference each year. We just enjoyed our 30th anniversary, totally unexpected for the rabble-rousers, and we're looking ahead to next year. Joe, care to comment?
Well, we looked back there in '94, '97, 2000 area. We're working, I mean, they're just the premier people in the world worried about 3D graphics decided to attack it with an ISO spec. And we're going to find the depths of that spec. The closer you look the more you'll learn. But a little a gem that they left us. There's a node called a transform that you set rotation, translation, and scale with. Well, they added this. They documented this another parameter of center of rotation that's relative to the translation, and it can be independent of the translation. Anyway, the more you study that, the more you realize what a gem they left us in terms when you want to animate a hierarchy. Thank you.
Yeah, and you can see that, and when we map these different variations of the same exact themes, it works in each case and different implementations. And having a standards process certainly helps with that. And it's reflected primarily what Joe described. That's our joint hierarchy and the skeleton. And by saying the joints have the animation and the segments on each one have shape geometry, well, that center allows that whole skeleton to ripple through, and you can localize every animation. You don't have to do global or real world coordinates for any of this thing. Further, skin means our mesh moves with the skeleton, and we don't have to have separate animations for any of that. So we found our design to be pretty portable. Everything in this slide set is linked into our spec or into other references. And if we get past the body part of it, then we've focused quite a bit on the animation, the motion of how we move these things around. So, Joe, I'm going to jump right in and start showing a few examples. These are all live on the web. Okay, here's one that's got skeleton, skin, and sights all at once. We can even with some of the tool developments, we can even edit live on the web. Let's risk angering the gods with that one. See if I don't know the exact RGB values for Khronos, but for Metaverse Standards Forum, but let's see how close I can get here.
Yeah, now
Okay, so that's
does
pretty
the skin
cool, and we can
binding
go
and
into Vermal encoding, we can go into JSON encoding. It's all equivalent, and we have different programming languages as well. The next demo is standard motion interpolators to push things around. Both of these examples, Joe's done most of the heavy lifting on both of these, and I'm just clicking on the buttons on the left, roll, walk, run. You can see it is live. We're not so worried anymore about going over the web. That's how it's been designed. We recently added a way to control lots of joints as poses, and we think this is an interesting way to author scenes with lots of behaviors in them. And we've also shown, boy, there's a lot of facial models out there, and many of them are proprietary or licensing. So people can convert those if they want, but we're not going to bring such things into the spec except as a capability that somebody else can do. But you can see here the facial animation coding system, action coding system, is a quite popular and been around for a while way to express many facial actions so that you can get a whole narrative of your facial animation corresponding to the body. Joe, I skipped over about 83 things. What should we tell this group in addition?
Well, I just want to mention that if you look at the animation coding for this, and you may find your authoring system picking your animations out in some kind of fixed thing like 25 frames per second or so. If you do
Okay.
the animation reasonable, and you don't
A little
need
louder,
to
please,
use
Joe.
the interpolators, you don't need that much data. That's okay.
All right, cheers. We're happy for people to get involved. Here's lots of tools and examples. We're adding a couple more examples just today. Here's our motion node in action. We found that BVH, BioVision Hierarchy Motion Standard, is not a standard. It's everybody likes it because that company went out of business apparently. So we've regularized it, normalized it, standardized it. There's a conversion. Since there are thousands of those things, we think we'll be
Motion
able to
capture.
use them. Many other tools here. I've been showing you Excite. We also have other open source and occasionally commercial tools that use this. So you can do it. Now, we have a special event now. I had hoped to link to more examples that are published in the slides, but we're going to have a guest demoer. Aaron, are you out there?
Yep, I'm here.
Can I give you the screen, please, sir?
Yep. All right. So yeah, we couldn't link to the models on the web today because it just happened to be that we had a server crash this afternoon. So can you see my screen?
Yes.
All right. So we got a couple of models here that are in X3D, exported out of Maya using the open source Rocky plugin for character export, well, for X3D export in general. Here is a model of a Neanderthal hand that my lab originally did 20 years ago, and it basically has been the evidence that Neanderthals could hold stone tools. But it's originally exported out in a Shockwave 3D, and of course that's not available anymore. I got a hold of the original Maya files after I rewrote the X3D exporter, and now we used it to export it out as an X3D HAnim animation. And as Don likes to say, it also proves that Neanderthals could swipe down on their phones. So here we have a test export from Revolution's character creator, which was brought into Maya and then exported using the HAnim export. And then here we have an advanced skeleton character that was exported out of Maya using the Rocky exporter. And I can show it here. Here we have the character rigged up as HAnim or as an advanced skeleton character, and go into different poses. Well, we just do a quick export, and we can go out to not only X3D but also JSON version of this. And then, of course, that's this one. Close it out, or I'll reopen it. That's to get the one I just exported. And this supports PBR texture or shading export. The primary one is a PBR export out of Substance 3D using the Unreal 4 packed version of PBR textures. But it offers a bunch of several different ways of doing it as well. So that's it. That's the demo.
Aaron, thank you. And so we've shown you guys a bunch of things. We have lots of useful capabilities. You've seen several of them. We are braced for scaling because we're all about the web. So that goes into every thought we have on design. Our work in progress is quite a bit. We're happy to see all the work going on with glTF because we've completely have glTF support embedded in inlining or in the native rendering. And we're looking forward to the work with VRM and perhaps even the referenced canonical skeletal framework, the interoperability there, just using it either as an import or directly. We further are working quite a bit on clothing. The 3D body processing group has been working for a while. We think that's actionable with pretty much the same skeletal design for the coveroid, human, humanoid, cover clothing, and coveroid. So excellent patterns to build on. And this relates closely to 3 different groups in Metaverse Standards Forum. You're welcome to get involved. Send people if you like. Get involved yourself. Look over our shoulder. And that's Joe and I. So thank you so much for your time today.
Thank you, Joe. Thank you, Don, and
Thanks, Don.
Aaron. That was really, really informative and helpful. So thank you all so much. All right, we're gonna move on to our next presenters. Nick Burkard and Ken Jakubzak from Meta are going to present on meta avatars, asset creation, USD, pipeline processing, and glTF at runtime. So over to you, Nick and Ken.
Hi again, everyone. So today we are going to, no, I'm not going to share. I'm going to click slideshow. Today we're going to be talking about the meta avatar pipeline. We'll be going over just general asset creation, how we use USD, how our pipeline processes our originating assets and modifies it, and then how we use glTF as our last mile transmission format. Again, I'm Ken Jakubzak. I'm a software engineer on the avatar platform team at Meta. And I'll pass it over to Nick.
Hey everybody, I'm Nick Burkard, and I'm a tech artist on working on avatars at Meta as well. And Ken, if you can move us to the next slide. Early on, in this iteration of our avatar pipeline, we've had many iterations, but early on in this iteration, we knew that we were going to have to build out many different types of avatar bodies and clothing in order to create a highly customizable parametric avatar. And so what we started with was building on USD as a source of truth for our source assets. And the way this works internally at Meta is that artists start out creating an asset in a DCC. They can choose to save out that DCC file, but really the thing that we care about are the USD files that are created. So in this instance, you can see there are a couple of different USD files that are generated from this artist. And one might be a mesh, the skeleton and skin weights. And all of these are kind of present as a separation of concerns. So we kind of like partition out the different types of data depending on what it is. And if you want to move forward, Ken. We use USD composition to bring all of these elements together, but we also use USD composition in order to we're saving out the constituent data of all of these pieces, but we can bring them together even without processing or combining them, and then view them together inside of USD View or any of our TCCs. Go ahead. Yeah, there we go. Using data inheritance with USD, this is really the kind of the key point of how we can scale and create many different assets. We use one base mesh or one base character to as kind of our base data, and then we start inheriting from there. And USD allows us to bring along all of that base information with those characters. What that allows our artists to do is they can see if you start out with one character, you can make some changes to some geometry, and then see if that data holds up on those the changes in the geometry. And if it doesn't, in this instance, we can do things like sparsely override components of data like skin weights, but then leave the rest so that it's kind of falling through back to that base data. This introduces a little bit of complexity to our artists, but it also allows us to move very, very fast. Go ahead, Ken. But ultimately, what this also allows us to do is it allows us to pull all of this data, all of this, piecemeal data into a large, kind of graph-based pipeline. And our graph-based pipeline is called, we internally call it the data-driven asset pipeline, but it has a bunch of different subgraphs, and whenever somebody on their phone or in a web interface or using a headset starts configuring an avatar, what they're doing is they're putting together pieces like subgraphs, pieces of these subgraphs, and these subgraphs get evaluated. They pull in all of this source data that our artists have created, and they combine together and create an avatar. Um, all of our graphs are authored inside of
We did
USD.
that, comma. It showed flexibility.
All of our graphs are authored inside of USD. And Ken, if you want to move forward one. This is the way that our tech artists author graphs. And so we call this Scrappy. It's a USD editor. What you're seeing here is I think this is probably me, but we're authoring prims to a USD stage. There's a viewport that we can see intermediate data when our data-driven asset pipeline is executed, and we can see the results of a combination of an avatar. From this, we can save out USD files, we can inspect them, we can layer in reference and author all the composition arcs that USD also provides. Go ahead, Ken. And then lastly, I'll hand this over to Ken, and he can talk about how we deliver glTF.
Yes, so we use glTF as the last mile transmission format. We convert all of our graph outputs, all the various bits and bobs that come out of our graph, and we slam it together. We make sure that it's ready to actually be renderable on device, and then we deliver it to our endpoints. And so in the context of delivering it to our endpoints, we have different requirements. We have different needs, right? And so to meet those needs, we have mechanisms to deliver different versions of our output based on those needs. So this might be enabling or disabling granular asset data. This might be selecting specific texture formats for specific optimizations for runtimes. It might be choosing to compress data differently or quantize data. It could be, hey, we want to optimize all the outputs into a single mesh, and we want to make it as optimal as possible for our runtime to actually operate and use. It could be saying, oh, well, we only want this LOD. We want like LOD 0 and LOD 1. We don't want LODs 1 through 4, just the two. And there are a bunch of other bits and bobs in terms of how we're able to pull these levers. But functionally, we have a very flexible way of manipulating what data actually gets shoved into the GLB and how that data then gets transformed. But that being said, it's not just delivery. We don't only do processing on the cloud and then deliver to our devices. We actually have a graph that really can run anywhere. It can run locally for TAs that are iterating on their assets or their graphs to be able to view and validate that the output looks the way that like it should. Like there's a very low res Maya example as well as a precursor to Graphy in the lower portion of this. Those are local workflows. As I've alluded to, we also have cloud infrastructure to run these graphs and to combine our avatars and spit it out and then deliver it to our runtimes like Horizon or our stickers that get produced. But then there's this third route. And as Nick alluded to, we actually operate this graph at runtime on device. And so if you pull out your phone and install Meta Horizon, which I know you're all clamoring to do, so I'll give you a minute to do it, and then I won't talk. Sorry, jokes aside, that's actually operating the graph. So we deliver a partial graph down, like we make sure that the bits that ought to be computed on device aren't done on device. And every manipulation that you see that's like moving like a slider or perhaps like doing an asset swap, we are taking the bits that we actually need to graph from the cloud and then compositing and running the graph locally. This is the case for Horizon on your phone. This is the case for if you're just interacting and editing your avatar in Messenger. It's the case if you're editing the avatar in VR. So we have a very flexible infrastructure that actually can run mostly everywhere. But as from let's go back to like 1,000-foot view. We've seen how we go from asset to actual runtime delivered avatar. And throughout the process of creating an asset and iterating on it, and then munging on it in a pipeline that can do a bunch of things, a bunch of transformations that can fundamentally change what the output looks like, there are overarching concepts that need to persist from start to finish. So, it's a given. Yes, there's a concept of a mesh. But functionally, then there are other things. Well, you have this rig and hierarchy concept that needs to be portrayed. There might be morphs that need to be portrayed as well to manipulate identity and provide customization options. And those have concepts from every step of this stage. But then how you represent it in the endpoint or the runtime, that's something that functionally there is really no actual standardization around or even way to conceptually convey it other than our own internal homespun thing. I could go on. I'm going to instead just say there are repeated categories of concepts that are probably pretty familiar to the folks on this call. But functionally, there are things that you likely have to implement over and over and over again. And this might sound similar to the previous talk that I participated in, but it's because it is the case. You likely have to implement your own concept of a behavior animation graph. You likely have to define what mesh views are present in your end format, and then you have to persist it through the pipeline. These are overarching concepts that are independent of format. And because some of these own concepts have proper representation in open source, those are fine, those persist, but others are purely self-serve. And this is due to a mixture of two things. They're arcane industry knowledge, or it's a given. Oh, right, LODs. It's sort of like a given. You would want that for a performant runtime that you then need to toggle between if you're trying to get every cycle out of your CPU. But this then results in no codified industry standards for these concepts. They're just sort of there, and every implementation has their own version or flavor of it. So what does this mean for us? From our perspective, we as an industry kind of need to acknowledge that there's always going to be a differentiated, opinionated standard for characters and avatars. But that doesn't mean that there are not commonalities and common concepts that actually exists between these opinionated standards or takes that could be codified and could be iterated on together. So we'd love to work and come together to establish character standards that inform file formats like USD and glTF. At the same time, we'd also love to contribute to translation frameworks between different standards. So, there might be recommendations on how to represent and convert them. It might even be between standards that exist. But we think that this is probably a good use of our time, and we'd encourage you all to participate as well. And that's it. I don't believe we have anything else other than a thank you slide.
Thanks, Ken. Thanks, Nick. Appreciate it. We do have about a minute left. Does anybody have a question for Ken or Nick? All right. I don't see any for now, so we will move on to our next presenter. Nick Porcino from Pixar is joining us to talk about reference canonical skeletal framework. So over to you, Nick.
Hi, well, I'm Nick Porcino from Pixar, and I'm here to talk to you about the reference canonical skeleton framework, just to repeat exactly what you just said. So let me share my keynote. All right, there's my title screen. Yes, please continue to share. Okay, so the reference canonical skeletal framework is a thing that we started working on, I guess, a couple of months ago, maybe a few months ago now, in the MSF forum for 3D graphics interoperability. And the point where we started was we were looking for things that we needed to define in order to be able to roadmap how you convert between file formats like FBX and and glTF in particular, but of course other exchange formats of note. We started with talking about vertex attributes, so that encompassed ways to describe, like, how do you say what a position is, or normal is, a UV coordinate, and so on. Coming up with a table of common definitions that we all agreed on. And we set up some guidelines for interoperability, talking about what's acceptable lossiness and things like that, and got to a white paper. So then we started looking around for, okay, that was air quotes easy. It only took like a year or something. What's next? And it seemed like the most important thing for us to look at was the one that everybody wanted to. Oh, I'm disturbing people. So I'm 1 second. The next thing people were interested in learning about was, or learning about, talking about, was character interoperability, and particularly a shareable skeletal hierarchy. So that precipitated the next effort, which turned into the reference canonical skeletal framework. So in that domain, we were talking about the application domains of DCCs, game development, and metaverse applications. That's pretty all-encompassing, but it's also kind of restricted. It doesn't necessarily, in the context of humanoid interoperability, doesn't cover general rigging, robotics, and other applications. It's specifically characters and avatars and their similarities that we can identify and document. So we went off, we got a whole bunch of standards, we analyzed them, and we pulled the list to study from production systems and research frameworks. So here's a quick bullet point list: BVH, ASF AMC, VRM, HAnim, SMPL, Mixamo, the OpenUSD examples, and Unreal's mannequin system, and Uni's Mechanim system. So what we decided after looking at all of those things was there's no such thing as a standard skeleton that everybody should conform to, but it did turn out that it is entirely plausible to map one hierarchy meaningfully to another hierarchy. And the idea arose of using a reference canonical skeletal framework as the pivot. In other words, the pinch point on the conversion process. Go to this format and then from this format without losing any information. So that study yielded like a giant spreadsheet, of which I'm only going to show you part of. It's got a dozen or more columns and something like 100 rows. Each row corresponds to a joint, and the exercise here was to identify the names of the same joints and or similar, conceptually the same joints across all these different domains. And this is just like the top. You can see we've got names of bones like thorax and lumbosacral. We've got names of soft tissues like lips and cheeks. But they are all kind of consistently available if they're available. So this chart is sort of kind of complete. It might be missing formats or domains that people really care about that we should look at. And we're also looking for volunteers to go through this thing. I constructed it until my eyes bled. There's several hundred entries, and it'd be great if other people got in here and started looking at those things and going, gosh, you spelled I wrong, or no, seriously, HAnim really does have a mouth, or whatever that I happened to miss. Actually, that HAnim when it says optional. This is work in progress. So once that was done, I wrote a little bit of software that would just take that entire spreadsheet and organize it into a tree, straight old computer science, because I'm a computer scientist. And I found out that, gosh, there is really just one hierarchy. There were not any things like in that giant table that were out of place. Everybody agreed that the foot bone is connected to the ankle bone's connected to the shin bone, etc. So that was a really interesting discovery. there's like one hierarchy. There's a set of core joints that everybody has. There's a bunch of optional joints that don't appear in all formats. And there's a variant, which is a twist joint that appears in some places, particularly for rotating your wrist. The thing that comes out of this is that you can, in fact, pivot between these things as long as you can specify what to do about extra joints or missing joints in the translation process. So part of the exercise that's underway of this process is to say, if you are got a 3-joint spine, and when you map it onto the 7 joints, this is what happens. And then if you map it onto something else with 5 spine joints, here's how to deal with it. That's the current work. So the next steps are to add since everything is based on, as it turns out, just standard human anatomy, the next steps are design the hierarchy for the reference skeletal framework using standard medical terminology, rather than, in many cases, the artist-driven choices for what the different joints are called. If we all agree that what it says, on a medical chart is means the same thing everywhere, you can get really, really far. So that makes sense as the pivot. We need to specify what we mean by joints and bones, because of course the joints are where the bones join, and we're naming things by the bones. What does it mean to name a joint or a bone? An effector is the end of a bone. It's possibly some arbitrary extra special thing at the end of a joint to offset from a joint. We need to specify how to talk about that. And there's hard joints, like say mandible, and soft joints or bones. Soft bones are those bones like lips. So I think HAnim does a good job of distinguishing soft from hard, and it would make sense to have something to say about that in the interoperability framework. And out of scope is everything else, like how do you bind the skin to the skeleton, and how do you animate the skeleton? And those are all well covered by many other systems, as we've been talking about today. And this whole thing is strictly about how do you get from one skeletal hierarchy to another skeletal hierarchy in a known and consistent way. So what can you do? You can go have a look at the current state of progress. Right now, it's still on my personal GitHub account, which is linked there. It'll move over to the MSF at some point, as probably in the new year when we pick up work and Steam. And please join the conversations and the MSF at the 3 Asset Interop Working Group. So that is my whirlwind tour.
Thanks, Nick. And Nick didn't tell you, but he is one of the co-chairs for the 3D Asset Interoperability Work Group as well. So we look forward to seeing you there to join us and move this work forward in MSF. So appreciate your time tonight or today, Nick. All right, so that concludes our presentations for this time. Now we're going to move into a roundtable discussion on character and avatar
before we do that, do I get any questions?
I'm so sorry, Nick. My bad. Any
I don't know, maybe we're
questions
good,
for Nick? Oh, Aaron Frank.
Yeah, go ahead. Maybe
Aaron,
your
go
mic
ahead
is
and
off.
ask.
Oh, can you hear me now? Oh, yeah. I shut off my microphone earlier just to double check that I wouldn't accidentally speak up when I wasn't supposed to. But anyway, Nick, that what you have here looks really cool to me. This is actually very similar to something that I've been working on recently, and I wrote some stuff in the chat, and I would love to collaborate with this on you. So as for like questions, like so you have your GitHub link and the this stating that about the MSF. Is there any other way to like get in contact with you? I'd love to like do like a direct collab with you if possible.
So I'm getting onboarded, thanks to Amanda, to the MSF platforms. At the moment, the easiest way to get me is Slack message at the SWF Slack. I'm sure I'll be properly available through MSF means soon enough. But before then, the SWF Slack, if I'm pretty sure you're on it.
SWF, what is that acronym?
Academy Software Foundation.
All right.
Oh, or if you're not there, you can drop a link. Or
Yeah.
if Amanda has quick advice, that would work too.
Yeah, I think Aaron, you're in our glTF 3D formats group, and Nick is actually joining Khronos as possibly as a liaison soon. We'll see. So we can definitely get you guys in touch with each other. A lot of this work moving forward with this specific framework is going to be happening in the MSF 3D Asset Interoperability Group, and we're looking for people to come and join that work and help champion it. So so we welcome you there as well. But yes, I'm happy to get you guys connected and make sure that you can contribute.
Thanks, Amanda. Thanks, Aaron.
Yeah. Nick, we have a couple questions in the chat. The first one is, well, they're kind of twofold. Are you looking at any gender differences or differences of the skeleton due to age or ability, such as in a wheelchair?
So the variability, this is a topological specification. It's not a geometric specification. It doesn't specify angles, limits, where the joints are positioned. So the differences that you mentioned for the most part are geometrical, as the bones that we animate are uniformly the same hierarchically via gender, unless if you've had an unfortunate incident in your life. So I guess the short answer is no, it's out of scope.
No.
But it's a very interesting question that we did think about. Was there another question?
Last question for Nick. Oh, wait, here's one. Or maybe it's a comment in the chat. HAnim bone length is implicit and determined by different joint center locations, then rendered by individual child segment shape geometry within each joint.
That's a comment more than a question, but the answer I think is the same as my previous answer. It's a geometrical question versus a topological one.
All right, so I don't see any other questions or hands raised at this point. So thank you, Nick. Sorry, I cut you short on your questions. I was rushing to get to the question section, which is next. So we'll move into the roundtable discussion where if you have previous questions, you'll be able to bring them. And also there's some general questions that Ken has ready to us. So I'm going to turn it over to Ken Jakubzak again to moderate our roundtable discussion. Ken?
Hi, everyone. So for the roundtable discussion, we have a few pre-populated questions just to get us kicked off. One of the things I'd ask is that as people are talking, if you want to respond or contribute to the conversation, just use the hand raise tool in Zoom so that you can cue yourself and make sure that we are able to get to you and to whatever you want to say. And that way we don't have folks talking over each other, and we can try to make sure that we get to everyone's. So for the top of the question queue, it's sort of a softball, I'm not going to lie. Given all the presentations that just happened, I asked the folks that were presenting, what role do you see actual inter-industry standards playing for character and avatar interoperability? What standards do you think are necessary to get this across the line? I know, actually, maybe it's not a softball. Maybe it's actually more of like a meteor, but they're both spherical. So, It could also be, I don't think there's a good way to use standards. It could be translation frameworks other way, such as the reference canonical skeletal framework, right?
Well, Ken,
Okay, I'll jump in, and we prepared simplistic answers to these powerful questions. We showed you all some standards, so you know what we think there. What's cool is the 3D Web Interoperability Group in MSF, where we think this is applicable. And so, if interoperability is the goal, well, web's a pretty good place to demonstrate interoperability. So we'll see if our standards work, if we can work with other standards, if there are going to be different families or perhaps a mix. It's interesting times.
well, I'm
So
amazed to see a lot of stuff going on here. That's for sure. But I think the idea, I kind of disagree with the people that are saying, well, there's no way it's too varied. We got to do, well, we have to establish the idea with the standard is that a new user can walk up to it and make use of it and being extensible. He's not going to run into a wall the next time he wants to upgrade the availability or functionality of it. It's just a prime place to start to make it open development with the World Wide Web and other creators and to share. So it's just the basic idea of the spec, I think, is give them a good starting point where they're not going to have to start over in a month or lose it for that matter in 3 months and they have to change platforms. So that's what we're looking for. And so as Mick has said, it's sort of at least standardized on the names and interfaces. And in HAnim, we realized that the animation points are the joints. So our scene graph is built in terms of joints. The bones are secondary. You find out how long the bones are by measuring the distance between the joints. So when somebody steps off of the platform of building the thing, hierarchy that's usually visible in a DCG, and he goes to animation, especially back to glTF. glTF has keywords of joints and skeleton. And so if those are standardized names, then the user at least has that to go on. And if we have standardized names for anything, it can be converted back and forth. And so far I've seen that a complete HAnim skeleton can be converted to others. Thanks. I'm rattling on there. Thank you.
So functionally, I think from my perspective, character standards for things that are non-controversial or likely don't have a lot of various in-studio, in-company variations are probably the first things that I would propose people start to address and try to rally around. And then creating translation frameworks with things that people likely have very opinionated takes on establishing, for example, names. Functionally, I don't really think the name of a shoulder is as important as the idea that it is a shoulder. And to that point, I also, maybe a little controversially, would say that for standardization of like things like skeletal hierarchies, standardizing the parts that compose the whole is probably more important than, say, do everything from the get-go. Having things be more modular might be a better approach, but that's not necessarily a hill I would die on. There's a question in the chat one question in the chat. I know, Aaron, you're next. But I do want to note that the question technically was queued up after. Are you okay if we go ahead? Well, you probably have a point here. Let's finish with your point and then go to the question.
Okay. Yeah. So what I'm going to say is basically a contrast to what Ken has been saying. And this is a topic that has come up quite a lot in the Khronos meetings for characters and avatars. It is a difference in philosophy. The idea of like, should we have a skeleton bone vocabulary or not? And even if the a vocabulary doesn't map perfectly to any given application, the idea of just having something that allows an importer or exporter to do like a mapping, to me is very valuable. Um, but there's questions over if that's actually something that we can standardize at this time. Uh, so yeah, I have like the a very contrasting opinion to Ken on this matter.
So let's get to the question that Priscilla asked, referencing medical names for avatar skeletons. Um, the question was around whether medical practitioners or medical groups have been involved in any of the work. I know that there was an assertion that HAnim has had folks involved in that context. Um, and so I just making sure I'm not missing anything. It just seems as though perhaps there's an inclination that using the medical names for particular portions of rig hierarchy might be preferred. Is that the intent here, Priscilla?
He says yes
I'll
in the
agree with
chat.
that assertion. That's the holy grail. And our use case is we're sorry, Mr. and Mrs. Jones. We had a wonderful scan of your child from 5 years ago, and if we had it today, it would help us give them the proper therapy, but that company doesn't exist anymore. Okay, so there's my use case. I hope somebody can dress that up for shared use, but we could make a strong use case for medical if we get competent at interoperability. Over.
And Carol also mentions an interesting point that English isn't the only language, but um, I think that for the purposes of interoperability, it's perfectly fine to use an index, an English label as an index, and have canonical tables, like if it's necessary to say this is what a tibia is in German or something, if it's not tibia. But I don't think it needs to be over specified because presumably these are well-known mappings because you don't have different bones in Germany than you have in another country.
So in lieu of any other questions, I think this kind of transitions, like we're kind of gravitating to that place. What do you view as some of the largest challenges for character avatar interoperability in the industry and reaching any sort of like true translation framework or even just standards overall?
I've got my favorite one. It's crossing that bridge of animating the constructing and animating the avatar with a transform, a glTF node that includes translation, rotation, and scale, but not center. Because using a center allows you to dimension the avatar in absolute terms. You put the center of the joint where you measure it out. If the node or transform does not include a center, then you're dimensioning the avatar structures relative, one relative to the next and relative to the next in that hierarchy. And so further down the road, that absence of center kind of drives a borderline between the ease of translating an avatar from one form to another and even animations involving that avatar. My favorite one, the transform without a center. We put it in there way back in 97, and every DCC has a way to do this, a way to offset that translation center of rotation from the basic translation of the part. And when it's under the covers, it's hidden, and we got to bring that out in order to make it easier, because that's really a gem that the originators left us.
I think my comment actually lined up a little bit with what Joe's saying. I think one of the challenges, from what I see is that characters just in general are so broadly used, and there's different applications, different fidelities of character representations. When you're coming from feature animation and you want to, try to figure out how does a character interop between DCC packages, whether you're modeling, animating, or rigging in something. You're generally kind of stuck in one thing. But then when you're in games and you're figuring out a transmission format, that's almost a different, it's almost a different question because it's a different almost a different fidelity. Those two worlds really haven't totally crossed yet. They're and there's at Meta with our avatar platform, we deliver to many different clients with many different performance specs. And so, what we deliver for an avatar might be different from one client than it is for another client. I think there's a baseline commonality between a lot of these things. I'm very interested in finding that. That might not be, what is a very specific thing named, but rather what is the representation of these things, that these concepts that kind of go beyond what we currently find in like USD Scal or glTF. But I'm very interested in expanding on that. But to Joe's point, in DCC packages, there are concepts of pivots, and in a lot of other places, those concepts don't exist.
You don't often see them in game engines because the decomposition of the of the pivot concept, as you see it in Maya, requires 9 matrix multiplications. And a game engine is going to go, I would like to have 1, please, not 9, thank you very much. That's kind of where pivots are kind of less commonly deployed.
I'll offer another challenge word for everybody, and that's validation. You can have problems you don't even know about if you're not trying to validate. We spent tons of time on this. Last week, we had an out-of-body experience when we tested on a new tool, and the skin would rotate, but not the skeleton, or maybe it was the other way around. And it was a hole in our validation that we fixed, and suddenly yet another tool is matching all the other tools.
I just generally think that this problem, it always like the biggest challenge is just people arguing over kind of the small stupid details that fundamentally matter, but functionally it just becomes a semantic argument. Like it's just like a labeling argument, and then everything degrades past that point. I know that's not really necessarily a very constructive thing to add to the conversation, but like realistically, that's where I see a lot of things start to dissolve. I've given this anecdote a lot in various meetings, so if any of you have heard this, I apologize. I have quite literally witnessed 2 technical artists in a professional setting argue over a rig hierarchy naming convention for 2 months because they didn't like each other's naming sense. They worked on the same team. They were trying to create the same product. It led to that getting delayed a bit because they just couldn't agree. I find it hard to believe that as a wider industry, we will not have similar issues when we start to talk about things on such a granular level rather than talking on a higher conceptual level first. And then at that point, figuring out translation between those higher conceptual buckets into the more granular like hierarchy or semantic descriptions. But and I'm starting to trail off, so I will stop myself there. Let's see. Is there any other questions? Does anybody have any other thoughts or questions that they want to ask the general group? There is one last question I have, but if anybody else on the roundtable or in the audience wants to ask a question, I think now is the time.
I had one question, which is we've seen a bunch of things that kind of like span utility from like very, very, very like microscopically nuts and bolts, like what I was proposing with the reference skeleton. And like just that's such an atomic corner of the problem, all the way out to like full web interoperability and stuff. And I see a lot of discussion on the side about expanding beyond characters and interoperability, which to me hints at rigs and things like that. Um, and I kind of feel like nobody's ever said the word rig because we're going just with the thing. And I kind of wonder if like half of the things people want to do, like retargeting specifically, have to have a notion of a rig to be meaningful. And then I wonder, are there any meaningful efforts in any standard bodies to deal with general rigs rather than the kinds of human skeletal hierarchies that we see in all the extant file formats I was able to personally identify, which absolutely do not have rigs in them.
Well, glTF has the core interfaces for a skin rig, a skin to skeleton, bind the skin to the skeleton joints.
Yeah, I
And
consider that a binding, though. I don't consider that a rig. I consider a rig to be a set of constraints. Like you can move this far and not that far. This is like how a clavicle moves. It has a prismatic motion rather than a ball joint motion. That's a whole other level that that the formats don't have, including glTF.
So functionally, this is something that I think longer term, the character and avatar TSG does want to start to explore how we would represent that in glTF. And I do think that it's probably something that extends to USD in some aspect as well. And so I would say that this feels ripe for potential translation translation framework extensions in the future for the work in the 3D Asset Interop group. Observer, Sam.
Yes, talking of rigging, we actually introduced constraints in VM 1.0, and these constraints are limited. These constraints only have limited features, but it's oriented to the avatar uses for like moving code face and twist bonds and things like that. So that's our case. So
and
yes,
also,
I
I'm
agree
interested.
that. I'm sorry.
Oh, go ahead. You're saying I
Yeah,
agree that.
I agree that we should continue to discuss about constraints or rigging in the Metaverse Standard Forum or the glTF site meetings.
Yeah, I agree. I think that VRM is maybe the more advanced interchange that I've seen in description of these types of constraints. But I would love to see them. I would love to see them start, being built and being described more frequently in the different authoring formats that we have.
Yep.
Yes, and given all these many assets we're seeing today, it's pretty cool. Metadata, how do we express the differences between this and that? And oh, we just re-rigged it and I saved it, and oh, we want to make it different again next week. MSF has a special role to play, I think. If we can get vocabulary that we share, it doesn't matter if you're using the one true rig that in the darkness binds them. It's you can speak to what's the same and what's different. That's metadata. And I don't know of any other forum besides MSF that allows us to have these conversations in such a meaningful way.
So I think we're out of time for the conversation. Amanda has appeared, which means that we are running out of time.
We are. Go
very,
ahead.
very quickly, it feels like we all kind of have coalesced on the idea of using the MSF's 3D Asset Interop group as a potential staging ground to have conversations around this. I guess one thing I'd ask for everyone is to just, put it on your calendar, join, and let's start talking. And then we can transition. Sorry, Amanda.
That's okay. Yeah, I was going to say the same thing is we welcome you into the MSF 3D Asset Interop group. We're excited about this project. And the other projects we do, of course, but yeah, we would love to continue this conversation, and if we see the need as we continue to move forward to have additional town halls, we can do that too. Ken did a lot of work, and I just want to say thank you, Ken, for all the work you did to push this forward and get it set up, get the speakers together. So thank you to Ken. But also thank you all for joining us, whatever time zone you're in. Thank you to all our speakers for sharing such insightful presentations and all for your engagement and questions. I think that today just highlighted how much progress has been made, but also that we still have a ways to go. So thanks for joining us to move this work forward. Participation is key. I know that you've heard that a couple times tonight, but I don't think we can say it enough. So please continue the conversation with us in the MSF working groups, contribute ideas, go onto the GitHubs that you saw today. These presentations will be available online on the MSF website and along with the recording and the slides. So please join us, get on the different GitHub PRs, contribute ideas, and let us help shape the future of the metaverse. Yeah. So thank you again for joining us. We look forward to seeing you in upcoming MSF sessions. Thank you, Kendra, for hosting us today from MSF. And we look forward to seeing you guys in a future MSF session. Thank you.